All right, so now let's answer the next two questions, questions 4 and 5. And as you see in this problem, there are two variables. We have an x and y. We're going to start off with the same thing. We're going to draw all three triangles. So here's our large triangle. There's a middle triangle, and there's our small triangle. Let me label it to make it look nice. Right angle, right angle, right angle. This is 18, because that's 12 plus 6. This is y. This is y. This is 12. This is x. This is x. This is 6. So if you remember from the last two problems, we started off with using the middle triangle and small triangle because they had this same side in common. So if we're looking at these two triangles, the x's are legs, and then the 6 and the 12 are also legs. So we're going to be using those numbers to find the geometric mean between them. So we'll have 12 over x equals x over 6. That'll give me x squared equals 72. X equals the square root of 72. And then we need to find the largest square that is a multiple of 72, so we can reduce it. Right there. So there's your answer for the variable x. X equals 6 square root of 2. And then we'll do the same thing for the variable y. So which two triangles contain the variable y? If you look at it, we have the large triangle and the middle triangle. They both share the variable y. Now let's put this value of x up into our problem. We want to put this, well, we don't need it in the small one because we're not using it. Let's put the value here. So I'm going to erase that, and I'll put 6 square root of 2. Now the question when we're solving for y is, now what value are we going to use since we have a y here and a y here, but we have an 18, and what other number will we use? Now, are we going to use the 12, or are we going to use the 6 root 2? Now, an easy way to do this is what we did back in problem 1 when we came up with angle measurements to help us write our similarity statement. So we're going to do that. So since this is our large triangle, let's say this is 40 degrees. Let's say this is 50 degrees. That one's smaller, so let's switch. Let's say this is 50 degrees. Let's say this is 40 degrees. And then the large triangle, middle triangle, they're going to share this angle. So this will also be 40. And then if this is 40, we know that this is going to be 50. So now we're going to use that as our reference to figure out which side to use. So we're going to draw a table. We're using the large triangle and we're using the middle-sized triangle. And then we're going to pick two angles that are opposite our variable y. So y is opposite the 50-degree angle, and y is opposite our 90-degree angle. If any of you are confused on how I did that, the y variable is opposite the 50-degree angle, and this y variable is opposite my 90-degree angle. That's where I got the angles from. So if we use this chart, we can set up our geometric mean. So then we'll have, in the large triangle, what is the side that's opposite to 50? That's my y. In the large triangle, what's the side that's opposite to 90? That's my 18. In the middle triangle, the side opposite to 50 is 12. In my middle triangle, the side opposite my 90 is my y. So we're going to use that to solve for our geometric mean. So we can do y over 18 equals 12 over y. We're going to cross multiply, and we'll get y squared equals 216. And y equals the square root of 216. Y equals, we need to find the highest perfect square that is a multiple of 216. And we get 36 times square root of 6. So we get y equals 6 root 6. And x equals 6 root 2. So those are our answers. All right, so we'll do the same thing. We have a right triangle with an altitude, and we have two variables. So let's draw our right triangle, the large one. We'll draw our middle-sized triangle. Some of you may say this may be the small one. It could be. And then we'll draw the last third similar triangle. Actually, let me scoot this over here, and then I'll put this over here. And then let's label our triangle. So we're going to have a right angle, a right angle, a right angle, and this is 14, this is x, and our blue triangle, this is 6, this is x, this is y, this is 8, this is y, and that is it. All right, so just like the first, question number 2 and question number 3, the middle triangle and the small triangle share that value of y. And we're going to be using the 6 and the 8. So let's go ahead and solve that geometric mean. So we get 6 over y equals y over 8. So we get y squared equals 48. And then the highest perfect square that can go into 48 is going to be 16. So that is your answer for y. Y is 4 square root of 3. And then let's put that answer into our middle-sized triangle, because we'll be using the middle-sized triangle to solve for our variable x. X is here, and x is here. So we're going to have a 4 square root of 3. All right, so we're using our large triangle and our middle-sized triangle. And we need to find the angles that are opposite our variable x. And I guess I didn't label that yet. So let's go ahead and do that. So it looks like this will be our, I'll make this 60, I'll make this 30. And these two share an angle. So this is 60, that makes this 30. So our variable x is opposite the 90-degree angle in the middle-sized triangle, and it's opposite the 30-degree angle in my large triangle. So now I can fill in the chart. So in the large triangle, I'll have x and 14. In my middle-sized triangle, I'll have 6 and x. And when I solve for the geometric mean, I'll get x squared equals 84. X will equal the square root of 84. And let's see, a perfect square that goes into 84. I think the highest one is going to be square root of 4, square root of 21. So that will equal 2 square root of 21. And that'll be my answer for